Hello dear, how are you all? Today in this video we will discuss about very important, very famous topic, mathematical induction. Induction was a mathematician who wanted to know whether any statement is true for how many integer. Because each statement is not true for all positive integer. For example, if we take a statement n factorial equals to greater than equal to 26, you know it is only true when n greater than equal to 4. When n greater than equal to 4, this statement is true, and when you take n less than 4, it is not true. Every statement is not true for all positive integer. So we cannot check any statement for each integer. In this way process will be so long. So we apply mathematical induction to find whether statement is true or not. In mathematical induction there are only 3 steps. In first step, we have to prove that statement is true for n is equal to 1. For example, if a statement is given us 1 plus 2 plus 3 n is equal to n times of n plus 1 by 2, it is a statement and we have to prove that it is true for all positive integer. We will prove it by mathematical induction. In mathematical induction, there are only 3 steps. In first step, we have to prove that it is true for n is equal to 1. We just replace n by 1 if both sides in statement, if both sides are equal. We say C1 is satisfied, that is condition 1 is satisfied. In next step, we assume it is true for n is equal to k, and when we have assumed that it is true for n is equal to k, we can replace n by k. In last step, we have to prove that, not assume, in last step we have to prove that it is true for n is equal to k plus 1 on the basis of our previous assumption that it is true for n is equal to k. In last, when we prove that it is true for n equal to k plus 1, it will prove that it is true for all positive integer. Hence, it was an induction method by which we can prove that statement is true for all positive integer. So, we will solve this example to understand better this. When n is equal to 1, 1 is equal to 1 times 1 plus 1 by 2. 1 is equal to 1. C1 is satisfied. C1 is satisfied. C1 is satisfied means condition 1 is satisfied. Now in next step, we assume that statement is true for n is equal to k. When we have assumed that it is true for n is equal to k, we can replace n by k. We can replace n by k. Because we have assumed that it is true for n is equal to k, and we call it statement B. Now in last step, we have to prove that statement is true for n is equal to k plus 1. How can we prove that it is true for n is equal to k plus 1? We add an expression. What should we do? Add in this statement to prove that it is true for n is equal to k plus 1. We should add an expression which can obtain by replacing n by k plus 1 in the left side of given statement. In each question, you have to add an expression which is obtained by replacing n by k plus 1 in the left side of given statement. When we replace n by k plus 1, we will get k plus 1. We should now add k plus 1 in given statement B to prove that it is true for n is equal to k plus 1. So we add k plus 1 in above statement B. 1 plus 2 plus 3 k plus 1 is equal to k times of k plus 1 by 2 plus k plus 1 by taking 2 as an LCM. K times of k plus 1 plus 2 times of k plus 1. By taking k plus 1 as a common, we will get k plus 2 by 2 k plus 1 plus 1 by 2. And this is the target expression as the same as required. This is the target expression. This is the target expression as given. So now it is true for n is equal to k plus 1. You see, if we replace n by k plus 1 in given statement, it will be same like this. So we can say that it is true now for n is equal to k plus 1. Hence, once we prove that it is true for n is equal to k plus 1, it will prove that it is true for all positive values of n. Now we can say that it is true for all positive values of n. So this was induction method by which we can prove that statement is true for every positive value of n. Thank you.